Hello, everyone. How are you doing? Thank you for attending this session on GitHub and Git Basics. My name is Wajahat Karim, and I'm currently speaking from Karachi, Pakistan. And today my session is all about GitHub and Git Basics. So I'm going with the assumption that a lot of audience today is consisting about students and fresh engineers or new engineers, and you may or may not know about Git. So if you are any kind of developer, then Git and GitHub is going to play a very huge role in your life and in your career. So this is fundamentally a very important core concept in the world of programming and in software development and engineering. So let's get it started. What is open source? If you have used Android or if you are a user of Linux, then you probably have heard this term open source. So open source is basically a software program which is publicly available on the internet, and you can read it, you can even contribute to it, and you can even make a copy and mess around with it. So that's what open source is all about. So there is a very common saying that software is eating the whole world, and then open source is eating the software. So basically, in this era, which we are seeing at this time, especially when we see that the software is running very heavily, especially in terms of like whatever you are, whatever technology you are working on, it gets updated very fast, like in number of days, or even sometimes there are multiple updates on the same day. So the primary reason for that is that most of the software is becoming open source, and it allows you to leverage the power of community. So there are lots of developers around the world in different time zones and different locations. They are contributing to the same software regularly, and this is why the development and speed and maintenance of those softwares have become very fast. So this is one of the biggest advantages of open source. Linux is the biggest example, and Android is another example of this. That how much big scale can you get with open source? So now, basically, this open source software is leveraged through a sort of version control system. So we have several version control systems, like we have sort of SVN, more like called subversion, and then we have Git. Git is a very popular and sort of de facto standard at this time in version control system. So Git was created by creators of Linux, and they actually sort of modified it, and it is also open source. So Git is basically a version management system which allows you to manage and trace the history of code. So you can think it like that, that you are working on something, and you have created one feature, and now you want to create a backup of it. So the usual way would be that you will create a file called as like variant1.zip or whatever, and then you move on and create some other feature. And once you are finished with other feature, then you create another file version 2. So this is how you end up with a lot of backup files, and uh, you know uh, taking your storage, and a very hard to manage and track. If you want to see that at one point you added this feature because that feature is causing some other problems and you want to remove that, then it will be very hard to do so. So that's where Git comes in, and it helps you manage a whole variant repository of your code, and allowing you to access any kind of backup at any point, and it's also a distributed system, so it allows a frequent teamwork system as well. So you are not only limited to single developer, rather you can actually utilize a team of 2 or 5 or 10 or even hundreds or thousands of engineers on the same project without getting into stuck into any problem or much conflicts or those sort of things. So it's very easy and it's very effective and productive to manage. So GitHub is basically hosted version of Git, server hosted version of Git. So there's not much difference in Git and GitHub. The only difference is that Git is an open source control system. So if you want to use only Git, then you need to host it either locally or you need to host it on some server. So GitHub just took that open source version and uploaded it on their clouds, and then they added, social features like following and searching and other repositories, and this is how it managed to become the biggest database of open source projects at this point. There are other services as well in replacement of GitHub. They are mostly Bitbucket and then GitLab, and there will be many others, and even a lot of enterprise companies who are very sensitive about their data and code base. They usually prefer to host their own Git system. So for example, if you are talking about Android, then Android is not managed on GitHub entirely. Rather, it's uploaded on the Google servers and it's managed by Google through extended version of Git called Gerrit, and they from time to time, push all their code base on GitHub for other people to view and understand it better. So usually we call Android sort of something like eventually open source, not regularly open source, but it's eventually open source. So, and now we'll go into some basic concepts about GitHub and Git. So first one is repository. So we have repository is like a container where you will be putting all your code of the GitHub. So all your code of your project and whatever. So this is actually the first point where you will have all the files, and also repository will be responsible to manage all the variant tracking and uh, when uh, when what happened, and it will allow you to go back into time and see previous code or even rebase to that code. So that's what a repository is. So this is the first thing. And then we have branching. So as I said that you can do teamwork with GitHub and Git. So basically you have branch. So branch is like a single line of your code. So usually the default branch is master. These days is called main. So we have a branch called as a man, and dots you see are basically these are the commits where you actually uploaded your code onto the branch. So now this is your work which we are doing, and you have taken it here, and then you have added some more code and added some more code and added some more code, and now when your feature is ready, you want to get it merged with your actual code base. So that's in the main branch. So this is how you actually leverage. On the same time, some other developer in your team is working on some else other feature. So they have created their own branches, and once they are finished with that, then they will be merging it. So overall, single branch will be maintained for the central code base, which will be live and uploaded on Play Store and servers and will be deployed. So this is basic concept of branching. We will go into the demo and see how it all actually works. So then we have a pull request. So pull request is on the GitLab and Bitbucket is called merge request. So they are basically same thing. So pull request is like you have a project which is available on GitHub, and someone else want to contribute to that. Someone else want to create some feature for you. So what they will do, that they will create a branch from your code and they will do their work, like I said in the previous slide, and then once they are ready, they will not be able to merge it directly to your code base, because you are the owner and you want to keep control of what code is merged and what code is not merged. So they will create a pull request. So pull request is like it will show you all the changes and what kind of commits contributor have made, and then you can actually review all those things, and you can ask for changes, and once you are comfortable with that pull request, then you can approve it, and as it's approved, then it will be merged into your code base. So this is how this whole open source ecosystem works around on GitHub, and the similar methodology is also applied in teamwork and enterprise companies for private projects. So for example, I am working on my company's Android application. So we have a team of 3 people in Android. So everyone creates different pull requests, and we review those pull requests and make changes and ask for changes. And then once all the problems are finished and verified, then we might those pull requests into our code base. So this is how everyone is contributing their part, living in different countries and cities. So what is a fork? So fork is your own copy from the original code base. So on GitHub, you will see a lot of open source projects, and they will be regularly updated. And so you want to create a copy of those projects and keep it to yourself and mess around with it. Oftentimes, we have requirements that we don't want to get it merged in the central code base. Rather, it is a specific requirement for our team. So that's where we actually use a fork. So fork is like we make a copy of we make a copy of the repository from GitHub, and then we make changes to itself. Now those changes will not be reflected to the original repository at all, and also the changes in the original repository will not be included in the fork in the future. So for that, we have some different rebasing mechanism where we pull changes from each of the repositories, which I will show a bit in the demo. So this is how a usual working is done on when you are doing Git. So we have first thing is we have a remote. So remote is basically a repository which is hosted on some cloud, on some central. So in our case, we will say that okay, remote is a GitHub. So we have a repository on GitHub. It's called remote repository. And now if any other developer want to contribute to that repository, then he or she will have to do first local repository. So that is done through git pull. So git pull is a command to pull the code from remote. So once that is done, then it will create a local repository in your computer. So every developer does this first, that git pull. So once your local repository is ready, then you have a lot of branches and a lot of stuff, a lot of separate tags and branches in that. So you start by check out any specific branch. Let's say you want to work on main, then you create it. You check out that main branch. Now that is becoming your working directory. So A little difference between working directory and local repository is like local repository is a clone version of remote repository. It have all the changes and commits and every past history of how code has evolved. So you can pull that anytime from there. Working directory is the actual code which you have at this point. So if you are working on master branch, then working directory will be master branch. And once you are finished with that and you want to check out some other branch, then check out that, and then working directory will be replaced. So any files which are in master branch and not in that other branch will be deleted in your local directory and you won't be able to access it. So this is how tracking is maintained on local repository and working directory. So once you have done some work on Git and you want to push it remote, then you first do is git add. So git add is like telling local repository that what files you are interested in to push to central repository and what files you want to skip it. So git add will be like that, and it will also keep all the changes which you have made. And there is a very nice diff preview to show you that how those changes are being done, like what lines have been added, what lines have been modified, and what lines have been deleted. So it's very effective. So once you are ready with all the files you have added for your staging, then you run the command git commit. So git commit is like actually pushing it on the actually telling that creating a record of those changes. So it's like git commit and you go ahead with some message like okay, feature one done, or finish first feature, or remove this thing, or those sort of messages. So it's like creating a record where you can go back at any point and reading that message you understand that what has happened in that single commit. So uh, mm, that's the first thing. And now once you are done with the git commit, now you actually uh, mm, you have to then do the git push. So git push is actually uploading. It's exactly not uploading, but to make context of what's happening in simpler terms, I am using the word upload, that uploading on GitHub server on your remote repository, on your actual repository. So that's how a simple cycle of local and remote repositories work. So that's all for me at this point in theoretical perspective. Now I will be showing you a simple demo. So I have started GitHub. So if you are, creating, if you are a student, then I would recommend you to create uh, your GitHub account with educational, with your university account. So GitHub provides some very nice features and discounts to the students. So you can read it on the GitHub education program. So they will give you different kind of discounts on, for example, Canva, and you can even get one free domain and some credits in Microsoft Azure, and some credits in hosting, and some domain name, and JetBrains IDs, access, and so I'd highly recommend you to go with GitHub education if you are a student. The only challenge is that you you have to, have an email of university domain. So at gmail.com or any personal emails will not work for this. So they will ask you for university email, and they will also verify your account. So it may take a day or two, but it's very good for students. So once your account is ready, and then you can actually see a feed of what are the people doing who you are following and showing interest. And here you can see all the list of repositories you have created. And here you can see all the repositories which are trending at this point in the technology you are interested in. So for example, I'll see mostly like Android and Tiger and those sort of thing. So now, first thing is that you will go ahead with create repository. And this is where templates come in. So templates are like pre-started packages where you don't have to do much. So it's optional. If you want to get it started with absolutely zero, then skip the templates. Okay, so when you have created account, you will see that there will be a username, and then you can also create other organizations. And organizations is like your team, company, or your some sort of structure where you want to include other people, and you don't want to share your credentials with everyone, and you will be giving access to those people. So those will be listed here as well. So repository name, it's pretty obvious. So let's say hello Git basics. So description, this is mostly like one or two lines, some basics exploring for GitHub. So the majority thing is public or private. So public is like anyone can see the code and anyone can use the code. And then there comes the different concept of licensing, which I'll not explain it here. But you can say that if some code is public, it does not mean that you can actually use it indefinitely. There is always some licensing mechanism involved for the project. So you have to make sure that if you are using their code base, then you are complying with their license. So private is like you will be able to only access it yourself. And if you want to add some collaborators, and then you will be inviting them yourself, and no one else will be able to access your code. So for example, we will go with public. So readme, I always say that readme is a soul to your repository. I see a lot of very interesting and amazing open source projects on GitHub, and but they don't have very good README, or they don't have README at all. So this is very important if you are working on some open source projects. I would also highly encourage you to create a README for private projects as well, because this will help you in onboarding other team members very easily once they read the structure. So README is more like what this project does, and how you can install it, how you can leverage it, and what instructions and what steps you have to do to make sure that code works on your local system. So those sort of things are added in the README. So for example, if I show you any README of any one of my library, eflip view, so you will see you can see that this is basically README. So anybody who is landing on this repository, you will see this, what this library does, and how developers can install it, and how can they use it, and uh, mm, mm, what are the problems into this library. So this is the first thing in your projects. So README is added in terms of Markdown file. So Markdown is a simple term of sort of markup language where you add it easily. Is supported by Medium, GitHub, and Stack Overflow, and most of the major platforms use Markdown these days. So we'll get into that a bit. So git ignore is like if you are working on some Android application or some programming software, then oftentimes there are files which are created by build process. So there are executables and cache files and those sort of files, and you don't want to commit those files to a central repository on GitHub, because anyone else who will clone that repository from GitHub will also get those files, and those can create problems in compiling on their PC. So for that perspective, git ignore is used. Git ignore is a simple file where you list down all the files and directories, and which files to ignore and what directories to ignore, and those sort. So for example, if I'm talking about Android, then it will actually skip all the build process, IntelliJ process, and JetBrains cache, and APK files, and those sort of files automatically. So git ignore template is, you can choose none, and you can create your own git ignore, uh, or you can choose one from here where you will be where they have a lot of template to choose from, like for JavaScript, for PHP, for Go language, and different kind of projects. So you will also be updating this as you go on with your projects at some point. But I feel that if I choose something from here, there is not much updates required. And then we have license. So as I said, that license is for the open source. So here there are some licenses which are used very commonly. Apache license is like you can someone else can use your code, and they don't have to pay you, or they don't have to give you any credit or something like that. So there are other licenses like MIT license and public license. So MIT license is like, okay, so you can use our code base, but you have to, mention our name in your product, whatever you are creating, more like giving credit. So we are not exploring license at this point. And then we have main branch. So this will be as a main branch, and if you want to change the name of this, and then you can do so with setting, but this will affect all your new repositories as well. So that with that. And then we have GitHub Marketplace, where there are a lot of different checks and integrations, and those sort of things involved. So if you have purchased some or installed some, then those will show here, and GitHub is asking that what kind of integrations you want to add in this particular project. So once you are done, then you go ahead and do create repository. So this is how your if repository will be created. So if you choose a README, then your README will be title and your description, which you have just added. But if you don't want, if you did not choose a README, then this is how your repository will be shown. Okay. So this will be an empty repository, And then if you want to add readme, then like I said, that it's a markdown file. So markdown file is like .md, and there are plenty of previews, and even VS Code also supports markdown preview. So the drill is very simple, that you have hashes for heading 1, then double hashes head 2, then triple hashes heading 3. So when you see the preview, then you can see that this is heading 1, heading 2, heading 3, and it's like that. Then if you want to make some uh, text bold, then you will be wrapping it with double star, and if you want to do italic, then it will be single star, and if you want to put some URL, then some URL, and this will be actual URL here. So if you see that, this will be actual URL, and this will redirect to google.com. So this is pretty straightforward, and images like image URL codes here, and it will be shown. So it's very straightforward, and you can read more about in details here. So you can also upload images and files and different videos directly by tracking here, and those will be added. So that's the first thing, that we have a repository ready. Now, what we want to do is that we want to, this is a remote repository, and we want to make a copy of it into our system. So there are many ways to make a copy. The first one is that you install some CLI on the PC. So you have different, CLI interfaces on GitHub, Linux, and everywhere. So, for example, you will be you will be running commands like git init or git clone, and then you will be putting a URL of here. So this is like that. Okay. So other easier ways are that you install GitHub Desktop. So GitHub Desktop is a software by GitHub themselves. It provides you with a very nice user interface to manage all these things. So I have seen people who prefer command line. I have seen people who prefer GitHub Desktop, and before that there was a tool called as Source Tree. It was very good, and I used to do a lot. And but these days I actually manage my whole ecosystem and GitHub from Android Studio plugin. So here we can actually see all the branches and all the commits of those. So it's mostly like any interface. So whatever it is, it does not matter as long as you know that what is your preferred tool, then it's fine, absolutely. So also someone messaged that Git Kraken and VS Code are also epic. I have heard a lot about Git Kraken. I have not used it personally, but I have heard a lot about it. That is very amazing. And also VS Code's GitHub support is also fantastic, really amazing. Uh, so absolutely. But again, a lot of people are comfortable with Git CLI a lot, so it's matter of choice. So for this demo, we'll be going with GitHub Desktop. So GitHub Desktop, once you install it, then you have to log into it with your GitHub account, and once you are inside that, then you will be seeing current repository. So this is the first section where you will see all your repositories. So if you want to clone repository from some URL, then you can directly put that URL, because a lot of times you want to clone some repository from GitLab or Bitbucket or some other repository. So that's where you will have this. So clone repository is like you are making a copy of remote repository onto your local machine. So if you paste the URL here, then it will ask you that where exactly you want to put it. But if you are using GitHub directly, then and you have logged inside GitHub, then you can actually search your repository here, and it will show you all your repository which you have. So for example, we have done hello git basics. So basically that's the same thing. This is coming from URL and this is coming from repository list, and on the behind the scenes it's doing exactly the same thing like this is coming from. And for the CLI, it's like you will run a command git clone, and you will put the whole URL. Uh, so okay, so we have created a clone repository, and now this is our current repository. And you can see that there is nothing here, no changes, and the history is like this is showing you the whole history of that there was initial commit which was created when we actually created a repository, and then I actually deleted readme file. So this is showing that this is deleted readme file, um, and this is showing that this file was deleted, and red lines are in a sense that okay, this was deleted. So and then we have branch. So we have only one branch at this point. So let's say I am a developer in your project, and I want to add some feature. So first thing is that I will clone the repository. So once I have cloned the repository, and now I know that what branch to pull from, so I have pulled it from main. So first thing is that I have to run the command git pull, which I showed you in the slides. So this is the button fetch origin. So what this will do, that this will update your local repository with whatever it lies on the server. So this is very important, that whenever you start your work in the morning or in the evening, whatever time zone you are in, the first thing you have to do is that you should run the command git pull and update your repository, because you don't know that so for example you are working, and there was someone else who worked in the night time, and they have put some code, and now you are behind it. So this is where git pull comes in. So now once you are ready with the latest code base, so first thing is that you have to create a branch. So let's say I'll go ahead with and create a branch, new readme. So I am choosing that this is a branch of new readme file. So I have created a branch. Now the thing is that this branch is only available in my local PC. This is not available on GitHub and at all. So for that, we have to actually push this branch on GitHub. So GitHub shows you this. You can do it at this point, or you can do it at later point when you have added some code base inside that. So for example, I want to push this branch now. So I have pressed the publish button, and it's live. So now, whenever I refresh this, I can see there are two branches here, and this can show me that there is new readme branch here. And if I choose the new readme, and then this is exactly same, and this shows you that this branch is up to date with the main. Okay, so for example, now we come here, and I open this repository inside, VS Code to make things more easier to edit. Okay, so I don't have anything here, so I just create a file, readme.md, and I say hello new readme. Uh, this is some code which have been written by developer A from Karachi. Okay, so now I have done this, and if I go into the GitHub, I can use the VS Code, but I want to show you the GitHub interface so that you get confused. Okay, so this showed me that there are one changes, and that one change is that readme.md, and the plus icon is like this is a new file which have been created at this point, and all the green lines are that these have been added. So if I want to now, if going back to the slide that we have to first run the command git add. So this is exactly like git add. So I have bunch of files like 3 or 4 or more, and I want to choose that which files I want to add in the commit. So I select those files here, and this is where I actually do commit. So I actually do a message that okay, added new readme file. So description is like there is something more explanation of what exactly code base is going, and then I just do commit. So once the commit is done, now remember that commit is done is like creating a record of what codes have you changed, but it is not available on GitHub actually at this point. For that you have to run the command git push. So for, you can actually do this with push origin, and this is also showing that you have one local commit waiting to be pushed to GitHub. So once you have done git push, all the files are uploaded, and you can see if you refresh here, you can see that in the new readme, you can see hello new readme. But if I go into the main, there is no readme because the new readme is inside another branch. It's not available in GitHub at this point. And now GitHub is showing you that the new readme have recent pushes. So it's showing you that compare and pull request. If I choose this branch, then it shows me that this branch is one commit ahead of main. So it's like uh, mm, there are two branches, and they are going in parallel, and now there is something being added in branch 1. At the same time there is something added in branch 2. So now they are getting compared. So branch 1 will say that branch 2 is ahead 3 branches, and branch 2 will say that branch 1 is behind 3 branches. So this is how GitHub will show you the whole terminology. At this point, it may feel confusing to you, but you will get used to it once you start, using GitHub. So now you saw that how we can create a branch, how you can publish the branch, and how you can make changes into the code base. Now we want to merge that code base into our main branch. So this is where GitHub Desktop will guide you on every step from here, that whatever you want to do, but also it will also guide you on GitHub repository actually itself. So if I choose compare and say that, okay, I want to create a pull request. So remember that pull request is like proposal. You know, so you want to create a proposal that, hey, I want to create this feature and I have done this work and I want you to review it. And if you like it, just go ahead and merge it. And so it's like a pull request. It's like a proposal. So first thing is that it will show you that uh, this pull request is coming from this branch, new readme branch, and then it shows you this arrow and shows you that this it will be merged in the main branch. And also there is this thing written that this is able to merge. So able to merge is basically that uh, mm, at oftentimes we get mixed in a scenario where we have conflicts. So conflicts are like, let's say branch 1 is changing readme file on line number 3, and at at the same time, someone else modified the line number 3 of README file in the main branch. So now pull request is confused that what change should it take? Should it take from the main branch or should it take from the new branch? So in that case, you will see not able to merge here with a red line, and you won't be able to merge it. So that's a bit of sort of advanced topic. We won't delve into that at this point. For now, we are going forward. So pull request is like, okay, you want to, title that what this pull request does and their description. And again, this is whole markdown thing. So you just put the description that how you have changed new README file and what have you added. Uh, so once you are done, then you have two options that create drop pull request and create pull request. So drop pull request is usually something which is more like pull request, but it will not be merged, it will not be reviewed by others, and it will be just for you. So, and the pull request is like, okay, create a pull request. So I am creating a pull request. Now what will happen that it will show you that how much commits this pull request have. We have added a new file and how much files have this changed. So this shows you that previously there are no readme file and now new readme file have been added. So now here you will be selecting that who will be reviewing your pull request. So you are like, okay, whoever this project have access to, they will be able to review it. So for example, if you want to invite someone, then you can do it like from here, that you can add their email or username, and they'll get an invitation, and then their profile will show up in the reviewers list and they can review your code. So assignee is like who the pull request is this, who have created it. So then we have labels like you can see that a lot of open source projects have different issues, and those issues they have like this GitHub Firefox. So, for example, we have the GitHub Mozilla here, and if we want to see that any project they have, so I want to go into that, and then I see that there are issues. So these are basically the issues the user have created, or there are problems and things, and these are the pull requests, and pull requests are like these have been coming from the open source contributors, Mozilla's own people, and in a way that they want to fix it. So on every title they have added this fixes 7151. So that means that there will be some issue whose number will be 7151, and this pull request is to fix that 7151 issue. So this will also link it, and then there are reviews and discussions. So these two people are reviewing it, and then these are the bunch of the comments they have made over the time, and then there is discussion going around. So this is how usually all the work is done. And then we have someone have requested changes. So as then the original developer have to create have to get back to those changes and modify the code based on what he have requested, and then he will review it again, and if he's satisfied, then he will go ahead and mark it as reviewed. Once it's reviewed, this will become green, and then you can merge it. So this is usually what happens with the pull request. So we are on our project here. Yep. So this is our pull request, and once you have now someone is asking you that please add some more description here. So what you do is that you go ahead into GitHub and you say, okay, I am creating today I am working on some other feature. So first I'll choose the main branch, and then I'll fetch the new code base, and then I'll create a new branch that okay branch 2, and now I am working on that, and I have not modified it at this point, and I am just uh, okay, so I am just going ahead and creating some other files, code files, dot Java, and some code, and so now I want to add this, and so I have added it. So I have added this code, and I am pushing it some code in branch 2. So now I have committed it, added it, and now only thing is that I have to run the git push. So since I have not pushed the branch as well, so once I do that, then this will also push the code itself as well. So now we have 3 branches. So now you can see that I am on branch 2, and meanwhile someone else have made the review on my previous pull request, which I have created here about readme, and he have asked me some changes that okay, please add changes. So what I will do, that I will select my original branch of that pull request, which is mentioned here if you forget the name. So you choose this branch and fork it. Even you can delete the branch from here very easily, and you can get back to that by checking out. So let's say I delete the README branch very easily. So I have deleted the branch here. Now this have only deleted local branch. This does not have affected my pull request or actual branch as well. So if you want to uh, address these changes which someone have asked you in the comment, then you go ahead in the branches and you choose the origin slash new branch. So origin slash new is like pulling a fresh branch from GitHub. So I have done this, and now this have created a local branch here, and again I'll put the fork, and this is showing you number 1, and this is basically telling you that there is a pull request of this branch created. So now I come back here again, and okay, this is confusing. So So now I am saying, okay, some more changes as per the review. Okay. So now if I come back to GitHub and I see that, okay, this line was deleted and instead this was added. So this is like modification. There will be more files and more. So there is a yellow icon. Yellow icon is like a modification. Green icon is like addition, and red icon is like. So I say, okay, address the changes requested, and you again commit it and push it. So once you have pushed it, then you can see that there is there is another commit after this message. So now you will again review it and you say, okay, this looks good. Let's go ahead and merge it. So they have merged it, and that's how uh, this whole comes in. And you can also delete this branch. So if you delete this branch, you can actually restore it at any point to get back to this PR. So now when we come back, you can see that master is the main is reviewed with all the new code where we have added in the README. So there will be only two branches now because new readme branch have been deleted. So this is how actual work happens, and there is a terminology called as git flow. There are different mechanisms, but git flow is very interesting in a sense that um, so this is a branching model uh, where you see that you have a master branch like main, and main is like maintaining all the versions which are live on Google Play. So 0.1, 0.2, 0.3. So anytime someone is working, they will be pulling a branch from it and called develop. And develop is like what is happening at this point in README or whatever. So they are like moving, and now someone is working on some feature, so they will be forking it from develop and adding. So this is feature one, this is feature two, and once they are ready, then they are merged into the develop branch again. So once so we have then those features are once those features are ready, then you will create another branch called as release branch, and that's where your QA happens. And if quality assurance is verified, then you go ahead and publish it on Google Play, whatever deployment target your is. So then you merge it into the master. So master is like anything which is deployed at this point. So if there is some serious issue with your new deployment, then you create a branch from master and you fix that issue and you send it back again for other users. And also you send that issue to develop as well, because if you do not do that, then develop will also contain that issue, and in the next release you will face the same problem again. So this is one of the ways usually things happen. There are other ways as well. So that was it. Much for listening. And if you have any questions, please let me know.